Now we're going to look at how to solve a few problems regarding to strong acids and strong bases. And before we're going to look at a few examples, here is a very quick reminder of what are the formulas that we're going to be needing in order for us to solve those problems. Number one, the pH formula is given as pH equals to negative logarithm times the concentration of H plus. Remember, H plus can be also written as, the H plus over here also can be written as H3O plus. They are the same thing. And then number two, to find the value of POH, we're going to use something quite similar to what we have over here, which is negative logarithm times to the concentration of OH minus. And if you have the value of POH and the question happens to ask you to find the value of pH, we can plug in the value of POH that you have found through the utilization of this formula into this relationship between pH and POH. Then you should be able to get the value of pH as well. So these are the three very, very important and very simple formulas that we're going to be using in solving questions regarding to strong acids and bases. Let's have a look at strong acids first. So in this question, the question wants you to find the pH value for 0.10 molar HNO₃ solution. So this is what the question wants. It's very straightforward. And then the question gives this. Questions gives the concentration of HNO₃. Is 1.01 molar. And what do we know here? That HNO₃ is a strong acid. This is a strong acid. So do remember that strong acid are completely dissociated in aqueous solution. So this is the definition of strong acids. We have talked about that in the previous video, so you can check it out. Okay, so strong acids are completely dissociated in aqueous solution. Why is this very important? Because by knowing the nature of strong acid, then we know that due to this, the concentration of H3O plus will be the same as concentration of HNO₃. So now we know that the given concentration of 0.10 molar for the acids. Therefore, because we know that strong acid will be completely dissociated in aqueous solution, therefore, the concentration of your H3O plus will be the same as the concentration of the given strong acid. So the first thing we need to write here is for you to write the complete balance dissociation formula. So we have HNO₃. This one is in aqueous. And then I'm just going to add water inside. Because it will be completely dissociated, so the arrow will be non-reversible arrow. and you will produce a H3O plus aqueous plus NO3 minus aqueous. So strong acids are completely dissociated, so this one will be completely dissociated to produce your H3O plus. So the concentration of H3O plus right there will determine the value of pH, because pH is defined as negative log concentration H3O plus. So now we know that the given concentration is 0.10. This is 0.10 molar. Because it will be completely dissociated, therefore this guy over here will also be 0.10 molar. So we're just going to plug in the value inside. So we have pH equals to negative log 0.10 molar, and the value would be 1.0. So that is the answer. So it's very important for you to have the balance equation. That one will be 1 mark in exams, and then this one will be 1 mark, and that one will be 1 mark as well. Okay, to have this balance equation written, you get 1 mark. That one, you get another 1. And by getting the correct pH value, you will get another 1 mark. Now, right here we have another example. So we need to do 3 things. We need to find pH, we need to find pOH, and then we need to find the concentration of OH minus for 0.020 molar HCl. So first we're going to write the balance equation for the dissociation of strong acid HCl. Remember, strong acid will be completely dissociated in aqueous solution. Therefore, the concentration of H3O plus will be the same as the concentration of your acid. So first we're going to write the balance equation. So we have HCl fully dissociated. Remember, we're going to use this arrow for strong acid because it is fully dissociated in aqueous solution. Then we get H3O plus so we know that the question gives you this concentration of the acid. So we get, this one is given. Because this is fully dissociated in aqueous solution, this guy will also be 0.02 molar. Okay, so now we can start to look for the pH. So, concentration of H3O plus is equals to concentration of HCl. Okay, so this is very important. The reason why is this the case? Because we are dealing with a strong acids, and strong acids, again, I repeat, is completely dissociated in aqueous solution. pH equals to negative log concentration H3O plus. So you do know that this is the same as concentration of H plus, and then we want to find pH. We're going to take this value. Okay, so we have negative log 0.02, and the pH value is about 1.7. Okay, so we have found, okay, you're gonna get 1 mark for the balance equation, 1 mark for the formula here, and then you get 1 mark for getting the right pH. So we're done with finding pH. So what about pOH? So to find pOH, what do we need to do? We're going to use pH plus pOH equals to 14. We're going to use that formula. We have found the value of pH. Okay, so we're just going to plug in the value there. You get 1.7 plus pOH equals to 14. Therefore, pOH will be 14 minus 1.7, and you get 12.3. Okay, you will get another 1 mark for this, and you get 1 mark for that one. Now, we have done for pOH. The last one is we need to find out the concentration of OH minus. And to do that, we're going to take this value here, value of pOH, because we do know that pOH is negative log times the concentration of OH minus. We know the value of pOH already. So pOH is equals to negative log concentration of OH minus, and we have the value of pOH, which is 12.3. 12.3 equals to negative log concentration OH minus. Okay, so when you solve this, you should be getting 5.0. So I'm going to just write it down here. The concentration of OH minus, you're going to get somewhere around 5.0 times 5.01 times 10 to the power of negative 13 molar. Okay, so you get 1 mark for this formula, and then 1 mark for your concentration. Okay, now we're going to look at a few examples for strong bases. The first one right here wants you to find the values of pH, pOH, and concentration of OH minus for barium hydroxide and right there, this one should be your molarity. Okay, that one is molarity. 0.00035 molar. The first thing we need to do is we need to write the balance equation. To write the balance equation for strong base, we don't have to include the water molecule inside. So you can just write like this. Fully dissociated to form 2 OH minus aqueous, and we have Ba2 plus being produced. Okay, so the balance equation now is like this. We do know that this one will be fully dissociated to form 2 OH minus. And we have told you just now, if you have 0.00035 molar over here, that one will be fully dissociated to form 2 mole of OH minus. Now, since this one is 2 mole, that one is 1 mole. Therefore, we can conclude that from this balance equation, we can see that 1 mole of barium hydroxide will be producing 2 mole of OH minus, but the question gives you 0.00035 molar of barium hydroxide. So what is the value of X? What we're going to do, we're just going to be cross multiplying. So to find this, so you're going to times that, divide by 1. So times, and you divide by 1. So the value of X, it's going to be 0.00035 times 2 divided by 1, then you get 0.0007 molar. So this is the molarity for OH minus, because you have 2 mole right there. Okay, if you go back to the strong acids, this is 1 to 1. You have 1 mole of HCl right there to produce 1 mole of H3O plus. Whereas this one you have 1, 2, 2. Okay, 1 mole of barium hydroxide to produce 2 mole of OH minus. Therefore, if we have 0.00035 molar right there, you should times 2 to get the concentration of OH minus. Thus, this is the concentration of OH minus that we're going to be using. Okay. So you'll get 1 mark for the balance equation. You'll get 1 mark for the proportionality and 1 mark for the concentration of OH minus for these strong acids. Now we're going to move on to finding the value of pH. But because we have found this one first, okay? Because of that, we're going to find out, we can find out the value of pOH. So we're just going to take that value, you're going to plug it into there. Then the value of pOH is about 3.2. Okay. So you'll get 1 mark for that one. 1 mark for this one. We have solve pOH. Okay, we have solved for that one. What about pH? And also, if you look here, we have found out the concentration of OH minus as well, which is this one, concentration of OH minus. So what about pH? pH, because we have this value over here already, plus pOH equals to 14. Therefore, the pH would be around 10.8. Get 1 mark and 1 mark. Okay, do remember that, guys. Strong bases are completely dissociated in aqueous solution. Okay, that is very important. Okay, now let's have a look at this one. In this question, it wants you to find the molar concentration of H+. Remember, molar concentration of H+. So what the question wants right here is for you to find the concentration of H+. Remember, H+ is also the same as H3O+. They are conceptually the same. The question gives this. So this is what the question gives. We have pOH value equals to 10.25. Okay. And we need to find the concentration of H+. So we're going to use that value to find the value of pH by using this formula. Okay, so we're gonna use this to find the pH. So pH is plus 10.25 equals to 14. Then you get 3.75. Okay. And we do know that from this value here, we can use this to find the concentration of H+. So now, from there, we're going to use pH equals to negative log concentration H+. The value of pH is 3.75. 3.75 equals to negative log concentration of H+. Okay, so you can do that with your calculator. So the concentration of H+ is, when you click that, you can have inverse log negative 3.75. So the concentration should be 1.78 times 10 to the power of negative 4 molar. Some calculator tip. Let's say we have 2.35 pH is given to you, and we want to find out the concentration of H3O+, like what we have done just now. So how do you do this? How do you punch this value into your calculator? So what we do is, first we're going to switch the negative sign to the other side, okay? And then log, when your log is switched to the other side, it will be inverse log. So how does it look like? So when you switch that over, when we move that log over to the other side, it will be inverse log 10. And then this negative sign moved to the other side, you will have that to the negative 2.35, like this. And you should be able to find out the concentration of your H3O+ for this example right here. Now, how do you execute this task on your calculator? It's very simple. So what you need to do is you need to press the shift button, and then you press the log button, and you should be able to see something like this appear on the screen of your calculator. And then after that, you just take that value, you type that in, and you should be able to get the concentration of your H3O+. You're going to get a reading over there.